Environmental monitoring is crucial in agriculture, smart homes, and industrial applications. Our project, the automated smart greenhouse system with rain fail-safe feature using Arduino, is designed to track key environmental parameters such as temperature, soil moisture, and rainfall. This system is built using an Arduino Uno as the main controller with multiple sensors working together to provide real-time data. The system displays this data on an LCD screen and takes automated action based on environmental conditions. For example, when it detects rain and simply triggers a fail-safe mechanism, which could be used to automatically close window, activate drainage system, or alert users to changing weather conditions. Similarly, the soil moisture sensor can be used to monitor irrigation needs, making it highly useful in smart farming application. This project aims to enhance automation, improve efficiency, and reduce manual intervention in environmental monitoring. So now, let's take a closer look at the individual components and their function.
First of all, there is the main brain. It's called Arduino. It is the brain of our system, processing data from our sensors. Okay, move on. There is the LCD display. It shows real-time temperature, soil moisture, and rain detection status. Next on, we have the soil moisture sensor. It detects soil moisture levels to monitor irrigation needs. And then there's a rain sensor. It identifies rain presence, triggering fail-safe measures. And then there's temperature sensor. It measures ambient temperature. And then last but not least is the servo motor. It automatically adjusts ventilation based on environmental readings.
Now, let's see our system in action under different environmental conditions. First, we start the simulation, but we need to set up our code first. So the highlight key for the code snippets, the code uses two libraries, which is server.h and the liquid crystal.h, server.h for the vents, and the second one is for the display. Now let's break it down. For the setup, initialize sensors, LEDs, and the LCD. And then for the loop, continuously read sensor data and make decisions. If it's too hot, which is above than 30 degrees, the vent is open. If the soil is dry, the pump activates. If rain is detected, the pumps turn off to save water. The system updates every 2 seconds to keep everything efficient. From this code. So let's start our simulation. For the temperature control, if it's above 30 degree, and then the vent is open. If it's below than 30 degree, the vent is closed. For the water management, if the humidity is low, the green light doesn't light up. But if the humidity is on the high intensity, the green light of the green LED will lights up. When the rain is detected, the red LED will lights up, and then if it's no rain, then the red LED will turn off. This shows how the system reacts dynamically to environmental changes.
So to conclude this project, we successfully demonstrated our system in action. As you've seen, it responds dynamically to changes in the environment, adjusting ventilation, detecting rainfall, and monitoring soil moisture and temperature in real time. The system is designed to enhance efficiency, minimize human intervention, and ensure optimal conditions for its intended application, whether it's improving agricultural sustainability or enhancing automated environmental controls. Our solution showcases the potential of smart technology in everyday scenarios. That's all from us. Thank you.